Wait a while, ma. Let me share my screen. Ma, give me host controls, no, so that I can share my PPT. I'm unable to share my PPT. Give me host controls. So let us discuss Unit 1, ma. First question. So in first question, different types of data models. So already I explained there are three types of data models. Okay, four types, sorry. So data model, we need first, how you are going to write means, first you need to explain what is mean by data model, write the definition of data model. So what is data model and what are the types of, you need to write down. First, write the definition, like data model is a metadata, right? It is a metadata. First, data metadata you write down about clearly information about the data models, and it is what are the collection of tools describing the data, data relationship, data semantics, data constraints. So what is mean by data model? It is a collection of tools which describes data, data relationships, data semantics, data constraints. And also after that you need to explain ER model. So here you need to write down like this. First, write the definition of data model. Like it is a collection of tools for describing four things: data, data relationships, semantics, and constraints. After that, you need to write a description about data model, like it is a conceptual tool which describes these all four things. And also you need to write about the database definition. It is a collection of interrelated data, and also defines what kind of data and what are the limitations of data is there. So main thing, you need to explain all these four things: what is mean by data, what is mean by data relationship, what is mean by data semantics, and what are data constraints. Ma, are you able to hear my voice?
Yes,
Yes,
madam.
ma'am.
So after writing the definition of data model, you need to explain that all the list of four data models. Like first one is relational data model, second one is entity relational data model, third one is object based data model, and fourth one is semi structured data model. So after writing, it is a collection of tools which describing data, data relationships, data semantics. What is mean by data? Data is a collection of information. What is mean by data? Relationship data which describes an relation between the entities. Coming to data semantics, which describes the meaning, which gives the meanings about data. What is about data constraints then? Data constraints are nothing but data conditions. Okay. So all these four you need to explain before writing all the four data models, and then you need to start writing the actual relational data model. So there are four categories of data models. So before going to write about the categories of data model, you need to mention one important point, that is why we are going to use the data models. We need to design the database at physical level, logical level, view level. That's why we are going for data models. What is the important point? We need to design the data at physical level, logical level, view level. So we are going for data model. So there are four categories. There are relational data model, ER model, object-based model, semi-structured data model. So let us see first one, relational data model. Basically, a database is a collection of, basically it is a collection of tables. Which one? Database. Okay. Basically, it is a collection of tables. Table is representing both data and table will represent data, and it is going to maintain about the relationship among data. Table represents both data, and it also should maintain relationship among data. Okay, that is what table. Table represents rows and columns, right? Attributes and entities. You need to write about that thing first. Explaining about relational data model. Basically, database is a collection of tables, and table it is going to represent both the data and as well as the relationship among the data. So table is nothing but columns and rows, entities and relationships. So if we are having two tables like student table and instructor table, the information is related to a student table is nothing but student database. The information or the data which is related to instructor or a teacher called as a instructor database. Okay. So if we are having student table and instructor table, obviously a student is related to a instructor. Obviously a student is somehow related to a instructor. How? A student, a teacher will teaching a student. Okay. So somehow a student is related to a instructor or teacher, nothing but relation. That describes a relation between the student and the instructor. Okay. So how it is showing the relation between the student and the instructor. So in a relational data model, everything in the form of tables, everything will be represented in the form of tables only. Okay, tables going to contain some multiple columns or multiple attributes. So here the one thing you need to remember, that every table should be has a unique name and unique columns. Unique name and unique column names. If you are having multiple columns with unique names in a database, that is called as a good database. Okay. So in relational database management system, tables are referred as a relationships. Okay. Tables, each and table, column, attribute, okay, a data, relationship, that are called as a relationship. Okay. A student, example, you can write like this. A student somehow related to a instructor or a teacher. Okay. So this relation model is also referred as a which one? Relation record based model. Relational model is also referred as a relation record based model. So record is nothing but a fixed format. Okay. So it contains several types of databases. So record is nothing but a record which defines a data in that a number of fixed number of fields or fixed number of attributes will be there. Okay. So this relational model is widely used. Now currently using the relational model is this thing only. So my widely most used this one relational data model. And also if you observe here, an example of a tabular data in the relational model consists of ID, name, street, city, account number. So if you observe here, how many columns are there? 5 columns. So which describes a complete description about the customer. Customer ID, customer name, customer street, customer city, customer account number. If you split this table also, again we can join the table. We'll get the same relation between the customer and the customer related table, customer database. Okay, let us see how we are going to split and how we are going to get the data. So relational database management system, it is a collection of database. Okay, collection of database is called as a tables. Table is a collection of fields, and fields are nothing but a tuples or records. Okay, or also we can go reverse, like collection of variety of various fields called as records, collection of fields called as tables, collection of tables called as database, collection of database called as RDBMS, relational database management system. So take this example: customer ID, customer name, customer city, customer street, account number. So from this table, we can create 2 more tables like customer ID, customer name, customer street, customer city, which describes the customer complete address. Okay, complete address of a customer. And we can also create 2 more tables with customer ID and the customer account number. And also we can create, if at all one more column is there, balance means we can create other table. So relational database, from the existing table we can create more tables. That shows the relation between the tables, that shows the relation between the data. Okay, so this is what relational data model. First you need to write the definition. So how you need to write the definition? Data model is a collection of all 4 related things: data, data semantics, data constraints, and also one more thing is there, no? That one you need to write. Okay, 4: data, data relationships, data semantics, data constraints. After that you need to explain about relational model, what is mean by relational model, and how we are going to uh, give a example, like how we are going to split the data. Okay, so in relational model, multiple relations will be there, multiple fields also will be there. Next, so this is a sample relational database. Like I explained, no? From customer, we can take a customer table, complete information about the customer. And second table as a account table, balance and account number will be there. And third table is depositor table, customer ID, account number will be there. Next, second one.
మేడం
అమ్మ చెప్పండి.
మేడం డేటా కన్స్ట్రెయింట్స్ అంటే ఏంటి మేడం?
Conditions. Constraints are nothing but conditions.
ఓకే మేడం.
Data semantics nothing but data meaning about the data. Constraints are nothing but conditions, like primary key is there. So what are the constraints about primary key? It should be null, yes or no, and also it should have unique values.
ఎస్ మేడం.
That is what constraint. Constraint is nothing but conditions. Data about the conditions which applies on data. Okay, so a particular thing, like we are applying some constraints, integrity constraint, domain constraints, right? So all that things, it is a collection of data, data semantics, data relationships, and data constraints. Okay, in that these are the 4 things, data models. So second one is ER model. ER model is nothing but entity relationship model. What is meant by entity? It is a real world thing or an object. And one more thing, relationship. It is a we can also say that a relationship is nothing but it shows the association between the entities and the attributes. Okay, relationship also you can write like this: the association between the entities and the attributes. What is meant by entity? Entity is nothing but real world thing. Okay. So here entity model is also referred as a ER data model. Entity is a collection of basic objects called as entity or a real world thing. Relationship, it will be defining the multiple fields. Okay. And example for entity is customer. Okay. Customer database and accounts, branches of bank, all those things, student related database. So that comes under the entity. Entity is nothing but a real world thing or an object. Customer is an entity. A student is an entity. Teacher is an entity. A bank is an entity. A branch is an entity. Okay. So each entity or each object is different from other objects. If you observe here, I'll just see. So this is an example schema in entity relationship. If you observe here, how many entities are there? Two entities. One is customer and second one is the account. So here it is depositor which is there, that is describing the relation between the customer and the account. Okay. So which is having the customer attributes like which, what is meant by attribute then? A property which is describing the customer called as an attribute. Okay. So customer ID, customer name, customer city, customer street, which describing the entity, that is called as an attribute. Next, coming to depositor. Depositor is a relation between the customer and the account. Okay. Even account is also having the attributes like account number and balance. So this is called as an entity relationship model. Okay. So like relational model, ER model is also widely used in the database design. So before starting to create a database, so how we are going to create a database? Like using the syntax, create table, table name. We are giving some attributes, some field names, right? Some data types. So before going to create that database, we need to draw this ER diagrams. Then only we'll be having the clear idea how to create and what are the attributes we need. Okay. So like employee works in a department. Works is a relationship between the employee and department. Like employee have a phone. Has a phone is a relation between the employee and the phone. And also a department contains a phone. Okay. So all those things will describe the entity relationship. Entity is nothing but a real world thing. A relation is nothing but it is an association between the two or more entities. Nothing but it is an association. Here, depository is an association between the customer and the account. Okay. Is it clear? Yes or no?
Yes, madam.
Next, object-based model. What is meant by object-based model? Object-based model, nowadays we are using the object programming languages like C, C++ for writing the programming languages. Like HTML also we are using for web designing the web pages. So mostly we are using front end as a programming languages, and back end whatever we are doing, like we are using some of the scripting languages, Oracle, SQL, like that we are using, right? So here for front end we are using the some of the programming languages like C++, Java, C sharp. So here object based is nothing but we are using some polymorphism, abstraction, inheritance, encapsulation, all those things comes under object based model. So using that as front end, back end we are using this scripting language data model. Okay. That is what object based data model. Object based model equal to ER model plus polymorphism. Okay. Next, coming to object relational data model. So here object based model plus relational model. So object is nothing but person. Here relational model is nothing but again coming to the ER, and ER model will be related to here. Okay. So you need to remember two things. We need object based model to run a scripting language, to run a data model. with the help of like programming languages, we are doing this one. So object based model equal to ER model plus, ER model is nothing but entity relation model plus again object oriented features. Why we are using object oriented features? To run a program. Okay. Next, semi structured. So semi-structured is nothing but here already we know some HTML languages, XML languages that will be in some semi-structured model. So by seeing that document, we can understand that it is a type of a document like XML document, HTML document, so and so program we have written, right? So name itself, it is giving a data, it is a semi-structured. So here it means it deals with a specification of data. Semi-structured data model deals with the specification of data. So it means individual data items of the same type have different set of attributes. Like I explained in class only, uh, we can HTML are predefined. Here we can write our own tags like describe. Yes or no? So this data model is used to transfer the data from the applications. This data model is used to transfer data among applications. Two applications of different need to communicate each other means we want to use. So here we will be using like some our own tags like note, from, to we can use, which are predefined tags. HTML are predefined tags, like we are having body, head, HTML, okay, all those things. Paragraph means p. So here in semi structured we can use our own tags. So it is similar to HTML, and HTML maintains predefined tags, whereas XML, we can create our own tags. Here in semi-structured data model, we are using XML, that is extensible markup language. Okay, like note, from, to we can use. Some of the other data models also there, but that are not necessary, that are not currently using now. Okay, so network data model and hierarchy model. So these are the two models we are not using now as of now. Okay, so understood this?
Yes, madam.
Yes. So next one, schema. This is very simple question. What is meant by schema? Schema is nothing but a logical structure of a database. Okay, logical structure of a database is known as a schema. Schema can be like example you can take, ma, you can write example creating a table like student table. In that schema, whatever the schema we are having, attributes like student name, student roll number, student branch and marks you can write. Okay, so what is schema? The logical structure of a database. The database consists of information about some set of customers account and relationship. And also here the logical structure of database is nothing but not only the columns, it shows the relation between the name of the database and the columns of the database. Okay, so here two types, physical schema and logical schema. Database design at physical level is called as physical schema. Database design at logical level called as logical schema. We already know abstraction, view, data abstraction, right? How many levels are there? Three levels: physical level, logical level, and view level. Okay. So here physical schema is nothing but a database design at physical level. A logical schema is nothing but a database design at logical level. That is what schema. So you can write the definition like it is a overall design of the database. Again, you need to write here the definition of database. Remember, every time you are writing means database means you need to write the definition of database. Okay. Database is nothing but it is a collection of tables. Again, table is nothing but it is an organized data which is in the form of rows and columns. So structure of database actually referred as a schema. Structure of a database. Suppose take this example. Here, this table which is there, this customer ID, customer name, customer street, city, account number, which is there. This is called as a logical structure of a customer. Okay. So forget about this, the data present in the table. Okay. The structure is customer ID, customer name, customer street, city, account number. Okay. Is it clear? Schema is nothing but overall structure of a database is known as a schema. So schema is of two types, physical schema and logical schema. Database design at physical level. Again, you need to explain about the view physical level. What is mean by physical level? You need to explain about physical level. It is the lowest level of abstraction. Databases are stored at physical level and deals with how data is stored, and it describes how a record is stored in a table. Okay, example, customer. So it also deals with the data structures. It involves a simple data structures to complex data structures, that also called as database levels. ఇది explain చేయాలి మీరు. Okay, you need to explain this about physical level. Next, coming to the logical level. Again, you need to explain about logical level. This is the middle level, and here the databases are actually stored, and also it is going to show the relation among the database. It describes the data stored in a database and relationship among the data. So here it involves simple to complex data structures, and also we can call it as it is a physical data independence. Okay. So all that you need to explain. First write the definition of schema, then explain about physical level and logical level. Okay. Is it clear, ma, or having any doubts? Guys, are you there? Yes or no?
Yes, ma'am.
Yes, ma'am.
ఏమైనా డౌట్స్ ఉంటే అడగండి, మళ్ళీ చెప్తాను నేను. ఓకే, నెక్స్ట్ ఇన్స్టాన్స్. Instance is nothing but the actual content of a database at a particular point in a time. ఈజీగా చెప్తాను వినండి. Instance is nothing but the information which is stored, okay, at a particular moment of a time is called as an instant. The information which is there that is stored at a particular moment of a time is called as an instance. Okay, what the difference between schema and instance? Instance is nothing but information which is there that is stored at a particular moment of a time is called as an instance. Coming to schema, a logic structure. A logical structure of a database is called as a schema. Okay, so here coming to the instance, again you need to write about the database. Okay, after writing the database definition, you need to write the instance definition. How we are going to write? It is a collection of information in a database at a particular moment called as a instance. Okay, so example, databases can change over time. You can write one example. How means that take our JN2K Kakinada example. In that now 100 are inserted, 1,000 players are inserted, and after 1 year after later, what will happen? Again, first year students will be taking the admission, and they are going to join, right? So for their information should also they are going to update the database. So there the database will be changed. Database will not be constant. Okay, database may vary. Database may change. That information stored at particular moment called as an instance. Okay, whatever the information we are getting today, I am having 100 records. Tomorrow I need to add again 100 records. Today is my count is 100. Tomorrow that count will become 200, right? So storing the information at that particular moment called as an instance. Is it clear? So here data can be added, data can be deleted. The database will not be same all the time. That is what instance. Information which is stored at a particular moment called as a instance. You can write this example like a university. Take the university example, and for university database, at that particular moment, how 1,000 tables are there. So after some months or after later or 6 months, 100 students are admitted. So what will happen? Again, the database administrator going to add the new student data so that it should be added, and the database will be frequently changing based on the request of the users. Yes or no? Instance is nothing but information which is stored at a particular moment called as an instance. Schema is nothing but a logical structure of a database. Again, schema is of two types: physical schema, logical schema. Is it clear? Yes or no?
Ma'am, once explain physical data independence, ma'am.
Physical data independence is nothing but it is in a logical view. Okay, what is mean by logical view? Logical view will deals with how data is stored, right? So physical data independence is nothing but here without if at all we are doing any modifications. Okay, we are having three levels, right? View level, logical level, physical level. So here physical level is the lowest level. In that we are going to see what data is stored, right? In second physical logical level, we are going to see what data is stored. Here whatever the modifications do in the logical level, without contacting, without the intervention of logical physical level, we are going to do the modifications. Ante without helping, without taking the help of physical level, we can do the modifications in logical level itself. That is why it is called as a physical data independence. Okay, so this will be application. This is also called as the application level, which is depending on the logical schema. Okay, so you need to remember three levels of abstraction. First one is physical level, lowest level, and logical level, second level, view level. In logical level, you are having physical data independence. There exists physical data independence. Whatever the modifications we are doing, okay, so without the help of physical data, we can do the modifications in logical level only. That is what physical data independence. Is it clear?
Yes, ma'am.
Okay. Next, data independence happen. Next, three types of schema architecture. త్రీ టైర్ అది టైప్స్ కాదు. సో త్రీ టైర్ స్కీమా ఆర్కిటెక్చర్, like application architecture, one tier architecture, two tier architecture, three tier architecture. So one tier architecture is nothing but where client, server, and database all reside on same machine. Okay, like Google form I have been created, like I am a client, you are a server. So suppose I have created one Google form to fill the details of your complete marks. Okay, so I am sharing my link so that you will going to enter your marks, right? So client and server related. So where client and server and database all reside in one machine. So all the information will be at one place, right? Example, Google form. That is one tier architecture. Coming to two tier architecture, a two tier architecture where here two layers will be there, presentation layer, so that it runs on a client and stored on a server. Example, transaction and withdrawing amount. If you observe here, two are there: user, application, database, system. So database system is used to store the data, right? Here in between application which is there, that is called as a presentation layer. So this is also called as a client. Two tier architecture is like a client and server. If I'm giving any request, like I want to open J into Kakinada website. Okay, URL I have given. What will happen after giving the URL in Google? It will going to redirect to the server of J into K, so that it is going to open that page, home page, right? So what is happening in this middle? It is going to my request is going to give to the server. Okay, then the server will open the home page, right? It is a client server. Presentation layer will runs on a client based on the request of a client and stored on a server. Example, transaction. Nowadays phone pay and Google Pay, all the transactions we are doing, right? If I am doing some transferring an amount from A to B, or some person, some 1,000 rupees, what will happen? Here I'm giving us some contact number, which is he is having the same contact number, and then only the transaction will be done successfully. Otherwise, what will happen? It is going to fail. Yes or no? And withdrawing money also. Whatever the correct information, accurate information, authentication is there, then only we can withdraw the money. Otherwise, we won't, right? We won't. Two-tier architecture also. How like if we are going to bank, means what we are going to do, we are going to withdraw the money, giving a request to the like we are applying for a ATM. What will happen? We are giving some letter to a bank manager, so that he will be providing a ATM cards for us. And similarly, for withdrawing money also, we'll be going to the bank and writing some information, account information. Then only after authorizing is nothing but here client is checking whether the given account number is correct or not. Then only he can authorize and provide whatever the need we are going to take. Okay, so whatever the need, what is our need? Withdrawing the money. So here client and server request will be there. Transactions, phone pay transaction, GPay transactions. Okay, so two-tier architecture. Next, three-tier architecture is nothing but here one more will be added. Application layer is added in middle of presentation layer and database server. So like web-based applications. Web-based applications are nothing but like just now I said no, URL I'm giving. In middle, what will happen? A database server will be there. Whatever the URL I have given, it should authenticate whether that URL is correct or not. If I'm giving any URL, wrong URL, means it is going to display it is incorrect, or we are going to get the some error occurred, right? Error occurred on a page వస్తుంది. Three-tier architecture. Same అదేమ్మా. So one tier architecture is nothing but it is directly available to the user. Any changes are done here, it will be directly done in the database itself. Example, Google form. Okay. So a person can be created the Google form who is the owner, and that is shared to the others to edit or fill the data. So that is a centralized form. One tier architecture, user will be there and database connected. Coming to the two tier architecture, it depends on the basic client server model. So generally two tier architecture is used in different programming languages like Oracle, Sybase, Microsoft SQL Server. So here two tier architecture, two layers untai, server layer and client layer. So database architecture where the presentation layer runs on a client, PC, mobile, tablet, and also our data is stored on a server called as a second tier architecture or two tier architecture. So here user will be interacting and application programmers will be run on the user interface. Whatever we are seeing in Google, the first page or whatever we are viewing, that is called as a user interface, and the application programs are run on the client side. So server side is responsible to provide the functionality of the query processing and transaction management. To communicate with the database, client side applications establishes the connection with the server side. That is what two-tier architecture. Okay. Next, three-tier architecture, it is an extension of a two-tier architecture. So here we are having application layer which can be accessed programmatically to perform various operations on Dbms. Like application will be there generally, presentation layer, application layer, database, server. So three layers will be there in three-tier architecture. So when we are going to search a particular thing on a Google will send the information to the server, and server it is going to provide information as per the requirement of the user. Yes or no? So when we are going to search a particular thing on a Google will send the information to the server, and server will going to provide information as per the requirement of the user. So in three-tier architecture, an additional presentation or GUI layer will be added, whereas in that only two things will be there: application layer and presentation layer. So only two-tier architecture. So coming to three-tier architecture, here GUI will also be added, like graphical user interface, and here end users who are going to interact with the database management system. Like examples, you can write best examples for three-tier architecture are web-based applications, login, sign-up pages. Okay, so this three-tier architecture has different usages with the different applications. So it can be used as a web applications and distributed applications. So this is about three-tier architecture. Is it clear? Yes or no?
Yes, ma'am.
Yes, ma'am.
Next,
Yes, ma'am.
Yes, ma'am.
next centralized architecture ఇవన్నీ అవేమా సేమ్ ఫిఫ్త్ సిక్స్త్ ఓకే నెక్స్ట్ ఈ ఎంటిటీ రిలేషన్ మోడల్ ఆల్రెడీ చెప్పానుగా ఎంటిటీ రిలేషన్ మోడల్ ER diagrams, how to draw ER diagrams if they are giving like shopping, online shopping means you need to write all the entities like customer will be there. Okay, ఇంకేమేమి ఉంటాయి అన్ని entities you need to write, attributes you need to write, and the relationships also you need to write. And constraints is nothing but one to one relationships maintenance, one to one to many, all those things you need to mention properly there about entity relationship. I'll show one example, see here, which is there in second PPT. Unit 1 part 2. First write ER diagram. So these are the components of ER diagram. And also you can use this attributes, key attributes, what is weak entity, composite attributes, multi-valued attributes, relationships like type of relationship, one to many, many to one, many to many, all those things, and mention this specialization like aggregation, composition. Okay, all those things you need to mention, ma. See here. So this is a diagram, a entity relationship diagram for university database. Okay, and this is a example of ఒక నిమిషం అమ్మ. ఇది payroll, ER diagram for payroll system. చూడండి అమ్మా ఇక్కడ. How many entities are there? Take this only example, or this you can take. ER diagram for hotel management system. So ER diagram for hotel management system lo we are having the entities customer, payment, invoice, has, bill, rooms, today price, room category, hotel. So information, complete information about the hotel management system. So again customer is having the attributes like customer name, country, email, all those things. Coming to the reservation. So in hotel we need reservation, right? Reservation ID, date, start date, end date, and how much long they are going to be there. Okay, today's price, available rooms, okay, all those things information like that you need to mention the ER diagrams. So if you observe here, today's price is dependent on the reservation. That is why double rectangle it is there here also. Okay, so you need to mention all the relationships, all the multivalued attributes, composite attributes, and then draw the ER diagram. Okay, so you need to mention complete information about the ER diagram to draw a entity relationship models. Is it clear? Yes or no?
Yes, ma'am. Yes, ma'am.
So let's go to second unit. మా ఫస్ట్ యూనిట్లో ఏమైనా డౌట్స్ ఉన్నాయా? ఏమ్మా చెప్పండి, ఏమైనా డౌట్స్ ఉంటే అడగండి. I hope you all clear about first unit. Yes or no?
Yes, ma'am.
Next, coming to second unit. So relationship models. Again, relationship models is nothing but here. Let me open unit 2. Relationship model. So relationship model and domain keys, constraints, integrity constraints. So relationship model, it is a database consists of collection. You need to write and have a, it should have a unique name. So consider a relationship like student table which have the attributes like roll number, name, address, phone, ఏజ్, బ్రాంచ్ కోడ్. ఇంతకుముందు డేటా మోడల్లో నేను ఏదైతే చెప్పానో దీన్ని స్ప్లిట్ చేసి రాయొచ్చు. ఎలా రాస్తాము? కంప్లీట్ ఇన్ఫర్మేషన్ ఆఫ్ స్టూడెంట్ ఈస్ వన్ టేబుల్ అండ్ వీ కెన్ రైట్ ది బ్రాంచ్ కోడ్ యాజ్ a second table, right? So converting a table into relational model, how? Roll number, name, address, phone as a student details. Coming to the student branch details, roll number, branch code. Why I'm again using roll number means to recognize the branch code of a particular student, we are writing the roll number again, roll number column again. Okay, is it clear? So relational model. Next one, integrity constraints. So integrity constraints are nothing but a set of rules, conditions you need to follow while designing the database. Okay, so it is used to maintain the quality of information. Integrity constraints ensures the data insertion, updations, and all the data manipulation things. Okay, so it has been processed to perform in a such a way that it should maintain data integrity. Integrity is nothing but accuracy. Okay, so here integrity constraint is used to guard against accident damage of databases. Even though any failures occur, by using integrity constraints we can maintain the data properly. So types of integrity constraints are domain, entity integrity constraint, referential integrity constraint, key constraint. So let us see the first one. Domain. Domain is nothing but whatever we are giving the column names. So it completely deals with the column names. Domain constraints can be defined as a definition of valid set of values for an attribute. The data type which we are giving as a domain. Suppose for ID I am giving as a integer data type, right? For name we are giving character. For semester we are giving integer and age integer. Even for semester we can use the varchar. Why? It is a mix of integer and the varchar characters, right? So here what are the data types of domain, including string, character, integer, time, and date, current, all those things will comes under a data type, so that we are maintaining one constraint that that domain should, or that column should be integer, means we need to give only the integer values. We are declaring the character means we need to give only a character values. Okay, suppose for ID I'm giving here names. Name is, will it a valid table? No. Why? I have declared the data type domain as an Integer. That's why I need to give only the integer values. Is it clear? Yes or no?
Yes, ma'am.
Next. So if you observe here, the age is having the varchar. So it is not taking. This is not allowed because age is a domain type of integer. Okay. Next. Entity integrity constraints. So entity integrity constraints states the primary key value cannot be null. Already we know the condition, we know the constraint of primary key. It should not be null and it should have unique values. So this is the because of primary key, it is a valid value. It is used to identify individual rows. Okay, and relationship. If the primary key has a null value, that we cannot identify the rows. The table should contain a value other than a primary key. Example here, see. Employee table is there, which consists of employee ID, employee name, and salary. So here, employee ID is there. It should not be null. Why? Because employee ID, we have kept the primary key condition. That means it should not be null. But here, it is an empty. Null values are not allowed in primary key. So that's why this table is an invalid table. Primary key should not have a null value. That is what entity integrity constraint. Relationship, it is showing yes or no. So EMP name is there, salary is there. How we need to identify? It is not showing any relationship, right? So that is what entity integrity constraints. Next, referential integrity constraint. Referential integrity constraint is specified between the two tables. Okay. So here referential integrity constraints, if a foreign key of table 1 refers to the primary key of table 2, then every value of foreign key in a table 1 must be null or it should be available in table 2. If you observe here, table 1, which consists of employee name, age, and department number. So here, what is the foreign key? Department number here. So here, not allowed as a department number 18, which is not defined as a primary key of a table. So that department number is a foreign key which is defined here, department number, and we can also create one more column name, that is location. So that by this second table, whatever taking as a reference from the first table, we are going to give a complete information of a department, like department number and department location. We are taking the reference of previous or existing table so that we can create the one more table. Is it clear? Yes or no?
మేడం ఇంకొకసారి ఎక్స్ప్లెయిన్ చేయరా?
Referential integrity is nothing but existing table untadamma. Okay, so from the existing table we are going to create one more table taking as reference of first table. ఇక్కడ రిఫరెన్స్ ఏంటి, ఏం తీసుకుంటున్నా నేను? డిపార్ట్మెంట్ నెంబర్ అనేది నేను తీసుకుంటున్నా. దాని నుంచి ఇంకోటి కాలం యాడ్ చేసుకున్నా. ఇప్పుడు ఏమైంది, ఇది డిపార్ట్మెంట్ నెంబర్ అనేది నాకు ఇక్కడ ప్రైమరీ కీ అయింది. ఎలా? నేను డిపార్ట్మెంట్ లొకేషన్ ఫైండ్ అవుట్ చేయాలంటే వీ నీడ్ డిపార్ట్మెంట్ నెంబర్. సో దట్ వీ కెన్ call it as a department number as a primary key. Okay, reference, we are taking the reference of previous table. Is it clear?
ఎస్
Yes or
మేడం.
no? Okay, next, key constraints. So key constraints are nothing but keys, the entity set that is used to identify an entity with entity set uniquely. So here ID is there, name is there, semester is there, age is there. So what is our key here? Primary key. I kept here for this column as a primary key. What are our two conditions? Primary key, it should not be null and it should be unique. If you observe here, 1000 is there, 1001 is there, 1002 is there, 1003 is there, again repeated 1002. It is invalid. Why? The primary key should not have the should be primary key will have the unique values. Is it clear? Key constraint, I have kept one key constraint, that is primary key for this ID. Is it clear? Yes or no?
ఎస్ మ్యామ్.
Yes, ma'am. Next, importance of null value. Importance of null values. So here null values are called as the special values that signifies the value of unknown or does not exist. Okay, for example, we have a attribute of phone number and the instructor relationship. See here, the problem of null values causes the number of difficulties when we access or update the database. Thus, they should be eliminated if it is possible. If you observe here, example, student is there, roll number, student name, address, contact. So how we are going to contact this person without this number? Okay, so that null value should not be exist in a table. Okay, so null values is also called as a unknown values. So here null values causes the number of problems, number of issues. So so that we cannot update the table. Okay, so that we need to eliminate the null values if it is possible. Is it clear? Yes or no?
Yes, ma'am. Yes, ma'am.
Next, tabular forms of creating a table and alteration of table. Okay, how to create a table? I have given the syntax, right? Create table, table name. Okay, so in table name we need to write. How we need to write? First field name. దీనికి ఎలా రాస్తారు? This is a create table. Table name is student. And bracket open. Enroll integer. Okay, next comma student name, varchar, you need to give the length, comma address, varchar, length you need to give 20 or 25, comma contact, integer, and you need to give length. Okay, bracket close, semicolon. My syntax తెలుసు కదా, చెప్పాలా? ఏమ్మా చెప్పండి.
No, ma'am.
No need, no. Alteration of tables. How to alter? Alter table, table name.
మేడం
అమ్మా చెప్పండి.
మేడం మీరు కాంటాక్ట్ కి ఇంటిజర్స్ తీసుకున్నారు కదా మేడం,
ఎక్కడ?
కాంటాక్ట్ కి
అవును.
అక్కడ నల్ అనేది ఎగ్జిట్ అవ్వదు కదా
నల్
మేడం, అంటే
అనేది టైప్ జస్ట్ అది మీకు చూపించడానికి నల్ అని పెట్టాను ఆ టేబుల్ అంతే.
ఓకే మేడం.
ఓకేనా? అక్కడ మీరు ఏమి ఇవ్వకపోతే ఏమొస్తుంది తెలుసా? నల్ అని డిస్ప్లే చేస్తుంది అంతే. ఒక
ఓకే
టేబుల్
మేడం.
క్రియేట్ చేసి చూపిస్తారు చూడండి కావాలంటే. ఇప్పుడు క్రియేట్ చేసే టైం అయిపోతుంది అమ్మా. ఒకవేళ టైం ఉంటే నేను చూపిస్తా. ఓకే,
ఓకే
నెక్స్ట్
మేడం.
డిఎంఎల్ ఆపరేషన్స్. ఆల్రెడీ వి నో వాట్ ఆర్ డిఎంఎల్ ఆపరేషన్స్. ఎస్ ఆర్ నో? Data manipulation language. So data manipulation language is nothing but it deals with the data. It deals with the data. So here we are having 4 commands. 4 ఉన్నాయి దాంట్లో. Select, insert, update. Select, insert, update. So how to ఇక్కడ చూడండి, data manipulation language, select, insert, delete, update. So for what we are using select? To retrieve the records we are using the select. Insert, why we need to use insert? To insert a records in a table we are inserting, we are using the command insert. Coming to the delete, if we want to delete a particular column, particular tuple, particular table, we are going to use delete as a keyword. Next, update, if I want to update the data in a table, we are going to use update. Okay, is it clear?
ఎస్ మేడం.
DML operations, very important questions, Amma. Next, unit 3, SQL functions. So దీంట్లో data manipulation language లో 2 classes of languages will be there. Procedure and non-procedure, you need to mention this one. User need to specify what data is required and how to get those data. Non-procedure, user specifies what data is required without specifying how to get those data. Only ఇక్కడ ఏం mention చేయాలి what data is required. So SQL is most widely used query languages. Select is used to retrieve the data from the database. Insert is used to insert the data into a table. Update is used to update the existing data within a table. Delete is used to delete the records from a database table. Next, coming to unit 3. So up to this clear, unit 1 and unit 2? Yes or no?
Yes, madam.
Structured query functions, huh? So arithmetic here, fundamental operations like select, project, union, set difference, Cartesian product, and additional operators like set, intersection, division, assignment, natural join. So here algebra operations, there are two types, unary operations and binary operations. So these are going, unary is nothing but operates on only one relationship. Unary operations will perform select, project, and rename operators. Coming to binary operations, these operates on pairs of relationships. These includes union, set difference, division, Cartesian product, equality join, natural join, semi-join operators. Select operator. First, ఎప్పుడైనా రాసేటప్పుడు గుర్తుపెట్టుకోండి, ఫస్ట్ డెఫినేషన్ రాయండి, తర్వాత సింటాక్స్ రాయండి. స్క్రిప్టింగ్ లాంగ్వేజ్ ఎస్క్యూఎల్లో ఎప్పుడైనా సరే అమ్మ ఇదే రాయాలి, డెఫినేషన్ రాయాలి, తర్వాత సింటాక్స్ రాయాలి, తర్వాత ఎగ్జాంపుల్ రాయాలి, కంపల్సరీ ఈ 3 ఉండాలి. ఓకే. సో అర్థమెటిక్ లాజికల్లో select operator is the first one, fundamental operator. The select operator selects the tuples that satisfies a predicate. Predicate is nothing but a condition. So here simply remember, select is nothing but it is denoted with the lowercase Greek letter sigma. S to start అవుతుంది select operator. So sigma కూడా S to start అవుతుంది. Yes or no? Next, coming to syntax, how you need to write the syntax? Sigma, condition, and relationship name. Okay, so we can also use the conditions in selection operators like comparison operators like equal to, not equal to, greater than or equal to, less than or equal to, and some conditions, multiple conditions like connectives and or not equal to. All those you can use in select operator. Select operator is represented with the letter sigma. Okay. Next, coming to the projection. It will select only a selected attributes. Okay. Select will select all the tuples. Coming to projection, it will select only a selected attributes. So it retrieves a column. Duplication is not permitted here. In a result, it will remove the duplicate values. So here the uh, syntax is projection, condition, relation. Next, Cartesian product. So here, as set theory, in mathematics, we are using the Cartesian product. It is also similar to, same here also. In mathematics, it is set of all pairs of elements x comma y that can be constructed from a given sets x and y, such that x belongs to y. So it defines a relation that is a concatenation of every tuple of R with every tuple of S. Here person is there, city is there. Every tuple of person is a Cartesian product of every tuple of city. Harry 3480 San Jose. Harry 3480 Austin. Okay. Or else you can write like this. Harry 3480 San Jose. Sally 2864 Austin. Next. Okay. George 2970 San Jose. Next, coming to complete oka record toni inko record Cartesian product, cross multiplication. Okay. Next, Sally 2864 San Jose. Next, George 2970 San Jose. Like that you need to write. Okay. Cartesian product. Next, rename operator. So rename operator is a unary operator which is represented with row R. R to rename. R ante rename. Okay. And also representation with row. Starting letter is R. You can remember like that. Okay. So union operator, same like set theory. So here union all, set difference. So union operator, it is denoted by U, and R union S means all the tuples of R and S it is going to give, but here it will going to eliminate the duplicates, whereas union all it will allows the duplicates. Intersection, only common elements will be retrieved. So division operator. Division operator takes two inputs, two relations called as dividend. R on scheme R, divisor relation S on S. Okay. So the output will be like this. See. A relational calculus, which is a non-procedural language, are again categorized into TRC and DRC. These are the non-procedural languages. So what
మేడం
is అమ్మా చెప్పండి.
లాజికల్ ఆపరేషన్స్ అంటే ఏంటి మేడం?
ఇవే ఫండమెంటల్ ఆపరేషన్స్ లోనే ఇవి ఉన్నాయి కదా, ఒక నిమిషం. ఇందులో కనెక్టివ్స్ యూస్ చేస్తామా, సెట్ ఇంటర్సెక్షన్, డివిజన్, అసైన్మెంట్, న్యాచురల్ జాయిన్, వీటిని లాజికల్ అంటారు.
ఓకే మేడం.
ఓకేనా. జనరల్ గా అట్లా అడగరు మిమ్మల్ని, అర్థమెటిక్ అండ్ లాజికల్ ఆపరేషన్స్ అయినా అన్ని అడగరు. దే ఆర్ గోయింగ్ టు ఆస్క్ ఎక్స్ప్లెయిన్ అబౌట్ రిలేషనల్ ఆల్జీబ్రా అని అడుగుతారు. అప్పుడు మీరు ఫండమెంటల్ ఆపరేషన్స్ రాయాలి, అడిషనల్ ఆపరేషన్స్ రాయాలి. ఓకేనా.
ఓకే మేడం.
నెక్స్ట్ సబ్ క్వెరీస్ అండ్ నెస్టెడ్ క్వెరీస్. So we know these concepts also. Subqueries, what is meant by query, what is meant by subquery. మరి ఇప్పటి వరకు అర్థమైందా, ఏమైనా డౌట్స్ ఉన్నాయా? ఎస్ చెప్పాలి మీరే, ఉన్నాయా లేవా?
అర్థమైంది మేడం.
లేవు మేడం.
అర్థమైతే అవుతుంది కదా. నెక్స్ట్ సబ్ క్వెరీస్ చూద్దాం ఒకసారి. So nested queries, a query within a query called as a subquery. Okay, and query within a query. Query, if suppose we are writing to retrieve the records of a customer, select star from customer, we are going to write a query within a query. Again, we want some customer details of complete who are buying this product. Okay, so for that type of questions, we are writing as a nested queries. Query within a query. SQL going to provide a mechanism for nesting subqueries. A subquery is select from where expression that is nested within another query. Okay. See here, it should follow some rules like AI can be replaced by subquery, and it is going to generate a single value, and RI which is there that is going to replaced by valid subquery. P can be replaced with an expression on the form of D operation subquery. Let us see with example so that you'll get clear idea. And also you need to follow some rules to create a subqueries. So a subquery is query within a query is another SQL query. The outer query which is there, if you observe here, I'll show you. ఈ బ్రాకెట్ లో ఉంది ఏదైతే ఉందో దీన్ని this is outer query. Select a distinct course ID which is there, this is called as outer query. The bracket which is there, this is called as an inner query. So inner query is also known as subquery. This one we can call it as a subquery. This is an outer query. This is also known as main query. Okay, main query, and this is a inner query or subquery. So all these concept, subquery, main query, inner query, that concepts called as a nested subquery. Okay. So first, if we are asking like explain about nested subqueries means you need to write the definition clearly that query within a query is called as a subquery. The SQL provides a mechanism for nesting these subqueries. A subquery is a query within another SQL query. ఇదంతే కదా. అనదర్ విత్ SQL query, the outer query which is known as a main query, the inner query which is known as a subquery. A subquery selects from where expression is nested within another query. Next, rules. So you need to follow some rules to create the subqueries. Subqueries always implement with select, okay, where having clauses. Okay, subqueries always, ఇక్కడ చూడండి, subqueries will always use where select having clauses. So subquery is always implemented with any DML statements. Again, DML statements are nothing but select, update, insert, delete. So subqueries always implement with DML statements. Select, update, delete, insert. So along with the operators like equal to, not equal to, less than or equal to, in between. So there are two parts left side called as outer query. Okay. Next, right side part is called as a subquery. 1 minute, ma. So coming back to this one, there are two parts, left side called as outer query, right side part is called as a subquery. Subquery always enclosed with parentheses, brackets. Okay, subquery is always enclosed with parentheses. Subqueries will not use order by command. Okay, you need to remember subquery always or will not use order by command. Instead of order by, we can use group by. That will perform the same operations as like order by. So this is example of subquery with select statements, subquery with update with, okay. ఓకేనమ్మా, అర్థమైందా?
మేడం ఆర్డరింగ్ అంటే ఏంటి మేడం?
ఆర్డరింగ్ ఈజ్ నథింగ్ బట్ అసెండింగ్ డిసెండింగ్ ఆర్డర్. ఇప్పుడు మనం ఒక క్వెరీ ఇస్తాం, ఇక్కడ ఉంది చూడండి. ఆర్డర్ బై, గ్రూప్ బై, ఇక్కడ చూడండి. ఆర్డరింగ్ ఇక్కడ ఉంది కదా, ఇక్కడ ఆర్డరింగ్ అంటే ఏం లేదు మా, అసెండింగ్ ఆర్డర్లో డిసెండింగ్ ఆర్డర్లో మనకి ఇప్పుడు సపోజ్ ఒక డేటా ఇచ్చాం, ఒక టేబుల్ ఉంది. ఏం టేబుల్ అంటే స్టూడెంట్ టేబుల్ ఉంది. సో ఐ వాంట్ ద స్టూడెంట్ టేబుల్ స్టార్టింగ్ లెటర్ ఏతో ఎండ్ అయ్యి లెటర్స్ జెడ్తో ఎండ్ అవ్వే లెటర్స్ కావాలి. లెటర్స్ అండ్ పర్టికులర్ లెటర్స్ కాదు, నేమ్స్ విచ్ ఆర్ స్టార్టింగ్ ఆల్ఫాబెటికల్ ఆర్డర్ A to Z means we need to give as ascending order. Like numbers, roll numbers you can take, like marks you can take, who are having above 50, they can be displayed means you need to give the order by, and order by పక్కన ఏమి ఇవ్వాలి, అసెండింగ్ ఆర్ డిసెండింగ్ అని ఇవ్వాలి. అసెండింగ్ అని ఇస్తే అసెండింగ్ లో డిస్ప్లే అవుతుంది. బై డిఫాల్ట్ ఆర్డర్ బై అని ఇచ్చి ఏమి ఇవ్వకపోయినా మీకు డిస్ప్లే అయ్యేది అసెండింగ్ లోనే. ఇప్పుడు పర్టికులర్ గా డిసెండింగ్ లో ఇచ్చారనుకోండి, చిన్న నుంచి పెద్దకి వెళ్తుంది. ఓకే,
ఓకే మేడం.
ఆర్డరింగ్ ఈజ్ నథింగ్ బట్ అసెండింగ్ ఆర్ డిసెండింగ్ ఆర్డర్ లో రాస్తాం అంతే. ఇక్కడ కీవర్డ్ యూజ్ చేయాలి మీరు, ASC ESC అని, అంతే. ఓకే, సో గ్రూపింగ్, సి హియర్ గ్రూపింగ్ ఈజ్ నథింగ్ బట్, సమ్ గ్రూప్స్ ఉంటాయమ్మా. ఇక్కడ అగ్రిగేట్ ఫంక్షన్స్ యూజ్ చేశారు. ఏది మ్యాక్స్, మిన్, యావరేజ్ అవన్నీ యూజ్ చేశారు. సో టు ఫైండ్ అవుట్ ద salary, average salary of the instructor in each department, we need to group. How? Select department నేమ్, ఐడి, డిపార్ట్మెంట్ శాలరీ ఉంది. ఎలా సెలెక్ట్ చేస్తున్నాం? డిపార్ట్మెంట్ నేమ్, యావరేజ్ ఆఫ్ శాలరీ యాజ్ యావరేజ్ శాలరీ ఫ్రమ్ విచ్ టేబుల్? ఇన్స్ట్రక్టర్ టేబుల్. గ్రూప్ బై డిపార్ట్మెంట్ నేమ్. గ్రూప్ బై డిపార్ట్మెంట్ నేమ్ అంటే నాకు ఎలా వస్తుంది అవుట్పుట్ చూడండి. డిపార్ట్మెంట్ నేమ్ వస్తుంది, నాకు యావరేజ్ శాలరీ వస్తుంది. ఓకే, గ్రూప్ బై సపరేట్గా నాకు ఈ కాలం రావాలి. గ్రూప్ బై నేను ఇప్పుడు శాలరీ అన్నాను అనుకోండి, ఐ విల్ గెట్ శాలరీ. గ్రూప్ బై ఐడి అన్నాను అనుకోండి, ఐడి యావరేజ్ శాలరీ. యావరేజ్ శాలరీ ఎందుకు? ఐఎమ్ సెలెక్టింగ్ ద యావరేజ్ శాలరీ. ఓకే, సపోజ్ ఐఎమ్ గివింగ్ హియర్ డిపార్ట్మెంట్ నేమ్, యావరేజ్ శాలరీ from instructor. Group by id means I am getting the table as id and salary. Grouping. Okay, next aggregations. Aggregation functions రాయొచ్చు. సమ్, మిన్, మ్యాక్స్ ఇవన్నీ రాయొచ్చమ్మా మీరు. ఓకేనా? అగ్రిగేట్ ఫంక్షన్స్. సో మల్టీ సెట్ ఆఫ్ వాల్యూస్. Average value is used to average value and minimum value. To count the minimum value of a given table, we need to use minimum. Maximum value of a table, we need to use the keyword as a maximum. To count the sum of the values, we are going to use the function as a sum. To count the number of values in a table, we are going to use the keyword as a count. Okay, aggregation functions. ఇంకోటి హ్యావింగ్ ఎందుకంటే ఫిల్టర్, ఫర్ ఫిల్టరింగ్ పర్పస్. హ్యావింగ్ ది సాలరీ గ్రేటర్ దెన్ 42. పర్టికులర్గా నాకు 10,000 అబౌవ్ శాలరీ ఉన్న వాళ్ళవే కావాలి అంటే నేను ఫిల్టర్ ఒకటి యూజ్ చేస్తున్నా. ఓకే, హ్యావింగ్ అది దానికి ఫిల్టర్ కోసం యూజ్ చేస్తారు. ఇస్ ఇట్ క్లియర్? ఎస్ ఆర్ నో? థర్డ్ యూనిట్ ఓకేనమ్మా?
ఎస్ మేడం.
నెక్స్ట్ ఫోర్త్ యూనిట్ ఫంక్షనల్ డిపెండెన్సీస్, ట్రాన్సాక్షన్స్ అని.
మ్యామ్ 4th and 5th యూనిట్ నోట్ షేర్ చేయండి మ్యామ్ ఒకసారి.
చేస్తానమ్మా, ఇప్పుడే చేస్తాను, ఉండండి. క్లాస్ అయిపోయాక చేస్తాను.
నాకు సెండ్ చేసిన మేడం, వాళ్ళకి పంపిస్తాం.
ఓకే. సో ఫోర్త్ యూనిట్ లో ఫంక్షనల్ డిపెండెన్సీ. ఇందులో యాసిడ్ ప్రాపర్టీస్ ఇంపార్టెంట్. యాసిడ్ ప్రాపర్టీస్ కంటే ముందు ట్రాన్సాక్షన్ కాన్సెప్ట్స్ ఉంటాయి. మా ట్రాన్సాక్షన్ అంటే ఏంటో రాసి ఎగ్జాంపుల్ రాయాలి. ట్రాన్సాక్షన్, బిఫోర్ గోయింగ్ టు ఫంక్షనల్ డిపెండెన్సీ ఐ వాంట్ టు ఎక్స్ప్లెయిన్ ట్రాన్సాక్షన్ కాన్సెప్ట్. సో ట్రాన్సాక్షన్ is a unit of programs execution that access the possible update. Transaction అంటే each and every time if we are doing any operations, okay, the whatever the operations we are doing, that immediately it need to update in database. So that is what unit of a program execution. Okay, a unit of a program execution that access and possibly updates the various data items called as transactions. So how we are going to write the transaction? If I want to transfer rupees 50 from account A to B, first we need to write begin and then read A equal to A minus 50. So that what will happen in second step? 50 will be deducted and it will be there in B, right? Next write A means here. Now the A will become 40. Then read B which is there, B equal to B plus 50. Now 50 will be added to B. And the last final thing, write B. So this is what transaction concept. Functional dependencies. So why we need to go for functional dependencies means to maintain the relational database design and also to maintain the features of a good relational database, we need to go for functional dependencies, all those things. Okay, so all the goal of relational database design is to generate set of relations.
మేడం
అమ్మా
సింగిల్
చెప్పండి.
కన్సిస్టెన్సీ అంటే ఏంటి మేడం?
Huh?
సింగిల్ కన్సిస్టెన్సీ
కన్సిస్టెన్సీ అంటే ఏం లేదు, డేటా ఇక్కడ ఉన్నది, డేటా విల్ బి ప్రెసెంట్ at different locations, right? That should be same everywhere, the data should be same. సింగిల్ కన్సిస్టెన్సీ అంటే డేటా కన్సిస్టెన్సీ ఉంటుంది, సింగిల్ కన్సిస్టెన్సీ ఉండదు.
ఓకే మ్యామ్.
ఎక్కడుంది మీకు, ఏ టాపిక్ లో అంటున్నారు?
అంటే నాకు ఒక టాపిక్ లో డౌట్ వచ్చింది మ్యామ్, అందుకే.
డేటా కన్సిస్టెన్సీ, సింగిల్ కన్సిస్టెన్సీ కాదు.
ఓకే మ్యామ్. ఓకే.
సింగిల్ కన్సిస్టెన్సీ అన్నా ఏం లేదమ్మా, ఒక డేటా ఎక్కడైతే ఉందో ఆ డేటా డిఫరెంట్ లొకేషన్స్ లో ఉంటది. ఓకేనా? ఆ డేటా డిఫరెంట్ లొకేషన్స్ లో ఉన్న డేటా ఈ ఏవైతే ఎక్కడెక్కడ ప్లేసెస్ లో ఉన్నాయో అవన్నీ సేమ్ ఉండాలి డేటా. ఇప్పుడు నా ఫైల్ నా దగ్గర యూనిట్ 1 ఉంది, ఆ డేటా అండ్ మీ దగ్గర యూనిట్ 1 ఉంది, ఆ డేటా ఇంకో దగ్గర యూనిట్ 1 ఉంది, ఆ డేటా సేమ్ ఉండాలి. దట్ ఈస్ వాట్ కన్సిస్టెన్సీ. ఓకేనా? నా దగ్గర ఇంకో డేటా ఉండి అదే సేమ్ ఫైలే కదా, నా దగ్గర ఇంకోటి ఉండి మీ దగ్గర ఇంకోటి ఉండి అది మిస్ మ్యాచ్ అవుతుంది. దట్ లీడ్స్ టు ద డేటా ఈస్ ఇన్కన్సిస్టెన్సీ స్టేట్. The data whichever the data present in different locations that is not same, that may leads to inconsistency. Okay na?
ఓకే మేడం.
Next, functional dependency. So functional dependency is nothing but functionally dependent. So here it is a relationship between the, 1 minute, let me open this PPT. ఒక నిమిషం ఆగండి. So before going to the functional dependency, let's see what is meant by decomposition. Decomposition interrelated ఉంటాయమ్మా ఇవన్నీ, అందుకని నేను అవి చెప్పి ఇవి చెప్తున్నా. So what is decomposition? Decomposition is the process of breaking down into parts or elements. It replaces a relation with a collection of smaller relations. So suppose this table is there. This table consists of how many columns? 1 2 3 4 5 6. So if we are going to split also, if we are going to join the table, means it should be same, the data should not be lost. Decompose చేసిన టేబుల్ ఏదైతే ఉందో ఆ టేబుల్ ని స్మాలర్ పార్ట్స్, స్మాలర్ టేబుల్స్ గా దీన్ని ఎలా చేయొచ్చు, కంప్లీట్ 1 టేబుల్ 2 టేబుల్స్ గా క్రియేట్ చేయొచ్చు. వన్ ఇస్ ఐడి, నేమ్, సాలరీ, ఒక టేబుల్ చేయొచ్చు. నెక్స్ట్ డిపార్ట్మెంట్ నేమ్, బిల్డింగ్, బడ్జెట్ ఇంకో టేబుల్ చేయొచ్చు. సో దిస్ టేబుల్ ఈస్ నథింగ్ బట్ స్టూడెంట్ టేబుల్ ఆర్ ఎంప్లాయీ టేబుల్ నేమ్, అండ్ దిస్ టేబుల్ ఈస్ డిపార్ట్మెంట్. Okay, department name, building, budget comes under. So this can be considered as a instructor and department table. So possibly the result will be like this. See, మనం decomposition అంటే ఏంటి? It is a process of breaking down into parts or elements so that it replaces a relation with a collection of smaller relationships. So it breaks the table into multiple tables in a database. So it should always be a lossless. Okay, even decompose చేసినా కూడా table ని the information will not should not lost, అందుకే lossless decomposition అంటారు. ఓకేనా? సో దాంట్లో ప్రాపర్టీస్ ఇవి ఏంటి? లాస్లెస్ డికంపోజిషన్, డిపెండెన్సీ ప్రిజర్వేషన్, ల్యాక్ ఆఫ్ డేటా రిడెండెన్సీ. సో లాస్లెస్ decomposition is that only. Decomposition must be lossless. It means the information should not get lost from the relation that is decomposed. It gives a guarantee that join will result the same. So employee department table ఉంది ఇక్కడ. సో ఎంప్లాయీ డిపార్ట్మెంట్ టేబుల్ కంబైన్ ఉంది ఇక్కడ. ఈఐడి, ఈ నేమ్, ఏజ్, సిటీ, సాలరీ, డిపార్ట్మెంట్ ఐడి, డిపార్ట్మెంట్ నేమ్ ఉంది. సో ఇఫ్ we are splitting or decomposing into two tables, one is employee table and the other one is department table. Employee table is EID, e-name, age, city, salary. ఇంకోటి డిపార్ట్మెంట్ టేబుల్ ఏమని రాయొచ్చు, డిపార్ట్మెంట్ ఐడి, డిపార్ట్మెంట్ నేమ్. ఇక్కడ చూడండి. సో these two tables I have decomposed. Even if I am joining these two tables, I'll be getting the same result, this table only, okay? But here I have taken one common column as EID, okay? Next, functional dependency. So functional dependency that exists when one attribute uniquely determines another attribute, okay? So if R is a relationship with the attribute X and Y, functionally dependent between the attribute is represented as X tends to Y. X tends to Y, which specifies Y is functionally dependent on X. Like student is completely dependent on teacher. So teacher is like student is functionally dependent on teacher. So here X is called as a determinant. Student is called as a determinant or identification key. Okay. Whereas teacher, that can be defined as a like dependency, functional dependency, right? So here X, student is called as a determinant or identification key, whereas Y called as a, it is functionally dependent on X. Y is functionally dependent on X. Student X aithe Y teacher. So student is completely dependent on the teacher. If R is a relation between the attribute X and Y are functionally dependent. So how it is going to representation? Representation is X tends to Y, which specifies Y is functionally dependent on X. X is called as a determinant or identification key. So department ID and department name can be determined as a department ID, department name. So this is functional dependency. Next, lossless dependency. ఇప్పుడే చెప్పాను కదా, lossless joint dependency decomposition. Next, 3NF, BCNF, multi-valued 4NF, normalization. See, first normal form. So why we are using normalization? Normalization is a process of organizing the data to avoid data redundancy, insertion anomaly, update anomaly, deletion anomaly. Anomalies is nothing but errors. Okay. So normalization is used to avoid these things. Insertion anomaly, inserting time లో వచ్చే errors ని insertion anomalies అంటాం. అప్డేట్ టేబుల్ ఎప్పుడైతే చేస్తానో అప్డేట్ అనామలీస్, అప్డేట్ చేసేటప్పుడు వచ్చే ఎర్రర్స్, ఇష్యూస్ ని అప్డేట్ అనామలీస్ అంటాం. డిలీషన్ అనామలీస్ ఏంటి? డిలీట్ చేసేటప్పుడు వచ్చే, ఇప్పుడు పర్టికులర్ ఇది ఉంది ఫంక్షనల్ డిపెండెంట్ అంటే ఎంప్లాయీ ఐడి సాలరీ మీద డిపెండెంట్ అయి ఉంటుంది కదా. సో లేకపోతే ఏ రేటింగ్ అండ్ సాలరీ తీసుకోండి. సో హూ ఈస్ హ్యావింగ్ ద రేటింగ్ ఆఫ్ 7, employee will be having the salary 50,000, means what will happen? Our salary is dependent on his rating. Yes or no? So here, if I want to delete a rating column, what will happen? Same salary column also deleted of the particular person. Avi deletion anomalies antaru. So here, in order to avoid all those things, we go for normalization concept. So normalization works through a series of stages called as normal forms. 1NF, 2NF, 3NF, BCNF, 4NF, 5NF. So what are the advantages with normalization? Means it will maintain the data in consistency state, correctness of data, integrity it is going to maintain, data integrity is going to maintain. So let us see one by one. What is first normal form? First normal form is nothing but a relation is said to be 1NF when it should have the atomic values, single values. Here, if you observe, employee will be having more number of contacts, more than one contact he will be having, right? So for that time, you need to write the table as a employee ID 102 John Kanpur some first number unit, right? Again, in second column, 102 John Kanpur, this number unit, right? See here, example. So this is the 1NF, nothing but it should have an atomic values. Next, as per the rule of 1NF, an attribute, it should not have hold any multiple values at a time. Okay. Next, 2NF. 2NF means a table must be a 1NF. Each attribute must be functionally dependent on primary key. Here, primary key means second point is very important here. No, instead of writing this, each attribute must be functionally either and. No partial dependency should be there in second normal form. That means primary key should not have any duplicate values. Okay. Example చూడండి ఇక్కడ. So this is a table having name like roll number, name and address. Okay. ఈ ఎగ్జాంపుల్ కంటే ఇంకో ఎగ్జాంపుల్ చెప్తాను చూడండి అమ్మ. నేమ్ రోల్ నెంబర్ బ్రాంచ్ ఉంది, లాంగ్వేజ్ నోన్ ఉంది. ఓకే, a person is having repeatedly name as Sai, roll number 21 CSE, and languages known Telugu. So here this we can call it as a 1NF. Why? Because it is having a single, right? Coming to the second rule, it should not have any partial dependencies. Means we can write only the roll number and the language name. If you take this only the table example, EMP ID ఉంది, EMP name ఉంది, EMP address ఉంది. 1NF rule satisfy అయింది. సెకండ్ ఏంటి? ఇట్ షుడ్ నాట్ హ్యావ్ ఎనీ పార్షల్ డిపెండెన్సీస్. అంటే ఇక్కడ ప్రైమరీ కీ షుడ్ నాట్ హ్యావ్ డూప్లికేట్ వాల్యూస్. ఇక్కడ ప్రైమరీ కీ షుడ్ నాట్ హ్యావ్ డూప్లికేట్ వాల్యూస్ అంటే వీ షుడ్ ఎలిమినేట్. ఇక్కడ ఈఎంపీ ఐడి 101, 102, 103, 104 ఉంది కదా, అది రాసి నెక్స్ట్ ఏం రాయాలంటే నెక్స్ట్ టేబుల్లో న్యూఢిల్లీ, కాన్పూర్, చెన్నై, బెంగళూరు రాయాలి. లేదంటే ఈఎంపీ మొబైల్ నెంబర్ ఇక్కడ ఇచ్చారు కదా, అది రాయొచ్చు. ఓకేనా? నో పార్షల్ డిపెండెన్సీ మీన్స్ ప్రైమరీ కీ షుడ్ నాట్ హ్యావ్ ది duplicate values. Next, third normal form. Third normal form is nothing but our table should be 2NF and there should not be transitive functional dependencies. Okay. This is used for only non-primary attributes. Suppose example, name, roll number, branch fee ఉంది. సో ఇక్కడ 2NF ఏంటి, 2NF 1NF సాటిస్ఫై అయిపోయింది ఈ టేబుల్లో. నెక్స్ట్ ఇన్ ద అబౌట్ దిస్ టేబుల్ ఇట్ ఈస్ గోయింగ్ టు సాటిస్ఫై 2NF. Each every row has single, there is no partial dependencies. Here coming to the second point, it should not have no transitive dependency means here the branch and fee. Suppose branch undi, fee undi. So that can be created in one more table. Name, roll number, branch ఒకటి రాయొచ్చు. ఓకేనా? నెక్స్ట్ బ్రాంచ్ ఫీ ఒకటి రాయొచ్చు. ఎందుకు? బ్రాంచ్ ఈజ్ ఫీ ఈజ్ గోయింగ్ టు డిసైడ్ బై ది బ్రాంచ్. దట్ ఈస్ వాట్ ట్రాన్సిటివ్ డిపెండెన్సీస్. Next, BCNF, it is an extension of 3 normal form. It is also called as 3.5 version normal form. It is an advanced version of 3NF. A table is said to be BCNF when it is going to satisfy 3NF. And for every functional dependency, it extends to Y means X should be a super key of a table. Okay. So here 2 tables ఉన్నాయి. Employee ID, employee nationality, employee department, department type, department number. ఇది 3.5 కదా, ఇది 3 నార్మల్ ఫార్మ్ సాటిస్ఫై అవ్వాలి. టేబుల్ షుడ్ బి 3NF and also it should not have or it should have it should not have dependency means A tends to B means here A should be a super key. Here EMP ID ఉంది, EMP nationality ఉంది. EMP ID should be a super key. In each and every table, if functional dependency is there means the X should be a super key. That is our concept here. EMP ID, EMP nationality, డిపార్ట్మెంట్ టైప్, డిపార్ట్మెంట్ నెంబర్ ఉంది. దీన్ని ఎట్లా స్ప్లిట్ చేయొచ్చు? ఈఎంపి ఐడి, ఈఎంపి నేషనాలిటీ రెండు తీసుకున్నాం. ఇక్కడ ఏది సూపర్ కి? ఈఎంపి ఐడి. నెక్స్ట్ ఇక్కడ ఈఎంపి ఐడి డిపార్ట్మెంట్ తీసుకోండి. ఏది సూపర్ కి అవుతుంది? ఈఎంపి ఐడి. డిపార్ట్మెంట్, ఈఎంపి డిపార్ట్మెంట్ టేబుల్ ని ఈఎంపి డిపార్ట్మెంట్ టైప్, డిపార్ట్మెంట్ నెంబర్ లో ఫస్ట్ వన్ ఇస్ ద సూపర్ కీ. దట్ ఈస్ వాట్ functional dependent. Y column depends on X means X should be a super key. Next, 4NF. Fourth normal form, it is a BCNF. It should not have any multi-valued dependency. So here student ID is there, course is there, hobby is there. So how we can write? A table will be multi-valued dependency if it is following the conditions are true. A dependency A is tends to B if a single value. If at all it is having a multi-value of B, there must be, the table must have multi-valued dependency. ఎలా రాయొచ్చు దీన్ని? స్టూడెంట్ కోర్స్ అనే రిలేషన్ ఉంటే స్టూడెంట్ ఐడి కోర్స్ రాయొచ్చు, స్టూడెంట్ ఐడి స్టూడెంట్ హాబీ. So this table we can create or decompose into two tables. One is student ID course and one is student ID hobbies. Why we are using common column as student ID? To recognize easily we are using this column, primary key as a column. సో దీనిలో ఎగ్జాంపుల్ ఏం చెప్పొచ్చు? బైక్ మోడల్ మ్యానుఫ్యాక్చర్ ఉంది, ఇయర్ కాలమ్ కలర్ ఉంది. సో హియర్ బైక్ మోడల్ మ్యానుఫ్యాక్చర్ ఇస్ వన్ కాలమ్, బైక్ మోడల్ కలర్ ఇస్ అదర్ కాలమ్. ఓకే. Next, fifth normal form. So fifth normal form is said to be 5NF if it is satisfying 4NF concept and also joint dependency. It should not have any joint dependency. So 5NF is satisfied when all the table present in the Dbms are broken down into many more pieces. We can make into any number of tables. We can decompose into many number of tables. So here subject lecturer class is there. We can make into subject lecturer, subject class, lecturer subject, like that we can decompose. Subject lecturer, lecturer class, subject class. 3 tables. Okay. So it should not contain any joint dependency. Is it clear? Yes or no? So this is about unit 4. Next, coming to the unit 5.
మేడం
చెప్పండి.
ఎంవిడి అంటే ఏంటి మేడం?
మల్టీ వాల్యూడ్ డిపెండెన్సీస్. అదే కదా ఇందులో ఉంది, మల్టీ వాల్యూడ్ డిపెండెన్సీ ఇందులో చెప్పాను. ఫోర్త్ నార్మల్ ఫామ్ లో అదే కదమ్మా చెప్పింది.
ఓకే మేడం.
మల్టీ వాల్యూడ్ డిపెండెన్సీ. నెక్స్ట్ ఫిఫ్త్, యాసిడ్ ప్రాపర్టీస్. So why we are going for acid properties? So acid properties, if a transaction satisfies the properties like atomicity, consistency, isolation, durability. Okay. So to make the database in a consistent way, the different locations, in multiple locations, the data which is present, that should be same. Nothing but the data should be in consistent state. So if at all while doing any transaction, if at any system failure occur means we are going to use the acid properties. Okay. If it should satisfy the acid properties, the data should be in consistency state. Atomicity, consistency, isolation, durability. A successful transaction changes a database from one consistent state to another consistent state. So in order to maintain the consistency of database before and after transaction, the data should be same. ట్రాన్సాక్షన్ కి ముందు ట్రాన్సాక్షన్ కి తర్వాత డేటా అనేది సేమ్ ఉండాలి. అప్పుడు అవుతేనే ఎలా సేమ్ అవుతుంది అంటే బై యూజింగ్ దీస్ 4 ప్రాపర్టీస్ దట్ ఆర్ యాసిడ్ ప్రాపర్టీస్. So why we are using acid means acid properties in order to ensure accuracy, completeness and data integrity. So why we are using acid properties? To ensure accuracy, completeness and data accuracy, we use acid properties. First one, what is meant by atomicity? If the transaction which is that should be completely happen or none of its operations. ఏవైతే ట్రాన్సాక్షన్స్ ఉన్నాయో అవన్నీ కంప్లీట్ అయినా ఉండాలి, లేదంటే అవ్వకుండా అన్ని అవ్వకుండా అయినా నన్ ఆపరేషన్స్ అయి ఉండాలి. ఓకే, ద స్టేట్స్ ద ట్రాన్సాక్షన్ ఇట్ షుడ్ బి అటామిక్. అటామిక్ మీన్స్ ఐదర్ ఆల్ ఆఫ్ ఇట్స్ ట్రాన్సాక్షన్స్ ఆర్ నన్ ఆపరేషన్స్. సో we call it as all or nothing rule. So if it doing some if ఏమైనా ట్రాన్సాక్షన్ చేసేటప్పుడు ఏదైనా ఫెయిల్యూర్ అయింది, one side of the transaction is failed means what will happen? Entire transaction going to fail. So this may leads to data inconsistent state. So here atomicity will be having two operations. One is abort and second one is commit. Abort is nothing but changes made to the database are not visible. Okay, are not visible, కనిపించదు. చేంజెస్ ఏవైతే చేసామో డేటాబేస్ కి అవి కనిపించవు అబార్ట్ అంటే. Commit means the changes made to the database are visible. After completion of transaction, it is going to show. Which one? Commit. అందుకని ట్రాన్సాక్షన్ స్టేట్స్ ఉంటాయి ఇక్కడ, 5 ట్రాన్సాక్షన్ స్టేట్స్. ఇక్కడ చూడండి, యాక్టివ్, పార్షియల్లీ కమిటెడ్, ఫెయిల్డ్, కమిటెడ్, అబార్టెడ్. సో 2 ఆపరేషన్స్ ఉన్నాయి మనకి అటామిసిటీలో. ఏంటి? చేంజెస్ మేడ్ టు ది డేటాబేస్ ఆర్ నాట్ విజిబుల్ ఇన్ అబార్టెడ్. ఎందుకు? ఇక్కడ ఫెయిల్ అయిపోయింది కాబట్టి ఏవైతే చేంజెస్ చేసామో ఇక్కడ మనకు రిఫ్లెక్ట్ అయ్యి ఇక్కడ మనకు చూపించదు. ఓకేనా? వేరాజ్ ఇన్ కమిట్ ద చేంజెస్ మేడ్ ఇన్ ద డేటాబేస్ it is going to show. Why? The transaction is completed successfully. సో ఇక్కడ ఏదైతే ట్రాన్సాక్షన్ ఉందో ఆ ట్రాన్సాక్షన్ స్టేట్ అనేది ఎప్పుడు యాక్టివ్ స్టేట్ లో ఉంటుంది. అది యాక్టివ్ స్టేట్ లో ఉన్న తర్వాత it is going to the second step, partially committed state. If the transaction is done successfully means it will leads to the data is in consistent state. ఓకేనా? ఇప్పుడు ఏదైతే ట్రాన్సాక్షన్ డ్యూరింగ్ ఎనీ system failure or system crashes occur, the transaction is failed means what will happen? The transaction got partial లో ఉన్న committed ది ఫెయిల్ అయిపోతుంది, అది ఆ ట్రాన్సాక్షన్ అబార్ట్ అయిపోతుంది, అది కనిపించదు. ఓకేనా? మళ్ళీ సేమ్ రిపీట్ అవుతుంది. ఎక్కడైతే ఫెయిల్ అయిందో అది మళ్ళీ స్టార్టింగ్ స్టేట్కి వచ్చి మళ్ళీ యాక్టివ్ స్టేట్కి వెళ్ళి పార్షియల్ అయ్యి కమిటెడ్ అవుతుంది. దట్ ఈస్ వాట్ అటామిసిటీ. ఓకే, so whatever we are doing the transactions, before transaction and after transaction, the database must be same. That is called as a data consistent state in atomicity. ఇక్కడ ఏ ఉంది? A equal to 500 T1, అది ట్రాన్సాక్షన్ రీడ్ అయ్యింది. ఓకేనా? ఏ నుంచి బికి ట్రాన్స్ఫర్ చేస్తున్నాం 100 అమౌంట్. ఇప్పుడు ఏ ఏమవుతుంది? 400 అవుతుంది. రైట్? ఏ అన్నప్పుడు వాల్యూ ఆఫ్ ఏ ఇస్ 400. నెక్స్ట్ బి ఈక్వల్ టు 200 T2 ట్రాన్సాక్షన్. ఇక్కడ ఏం చేస్తుంది? రీడ్ బి ఈక్వల్ టు బి ప్లస్ 100. సో హియర్ 200 ప్లస్ 100 is 300. నౌ ద వాల్యూ ఆఫ్ బి is 300. సో బిఫోర్ ట్రాన్సాక్షన్ ఎంత ఉంది? 500 ప్లస్ 200. ఏ ఎంత? 500. బి ఎంత? 200, 700. ఓకేనా? ఆఫ్టర్ ట్రాన్సాక్షన్స్ ఏమైంది? రైట్? ఏ ఎంత అయింది? 4. బి ఏమైంది? 300. సో బిఫోర్ ట్రాన్సాక్షన్ 700, ఆఫ్టర్ ట్రాన్సాక్షన్ 700. సో ద డేటా ఈజ్ ఇన్ కన్సిస్టెంట్ స్టేట్. So if transferring A to B before transaction fail అయింది అనుకోండి, after T2 the T2 will not be deducted. Okay, it will not be added. What? So the data will be in inconsistent state. Suppose T1 అప్పుడు నేను ట్రాన్స్ఫర్ చేసా 100ని, ఇక్కడ 400 అయింది, బట్ ఇక్కడ రిఫ్లెక్ట్ అవ్వలేదు. అంటే ఏంటి? ఇక్కడ 200 ఉన్నది. బిఫోర్ 700 ఉన్నది కాస్త ఒకవేళ ఫెయిల్ అవుతే 600 చూపిస్తుంది. ఓకే, దట్ ఈస్ వాట్ atomicity. Coming to the consistency, Consistency is nothing but correctness. So the transaction, when it is going to start the execution, it should be in a consistent state. So during transaction execution, the database may be temporarily in consistent state. So the sum of A, B is unchanged the execution of transaction. Integrity constraints should be maintained so that the database will be in consistency state. ఎప్పుడు కరెక్ట్నెస్ వస్తుందంటే మనం we need to use the integrity constraints. Again, what are the integrity constraints? Domain constraints, key constraints, referential integrity constraints. Again, first unit. ఓకేనా, అందుకే ఒకదానికొకటి ఇంటర్ రిలేటెడ్ అమ్మా ఇవన్నీ. నెక్స్ట్ ఐసోలేషన్. Isolation is nothing but the transactions or actions performed by the users will be isolated or hidden from the outside transaction until it is going to terminate. So the transactions will be isolated, will be in isolated mode. So data used during execution of the transaction cannot be used by other. ఎందుకు? ఫస్ట్ ఇక్కడ మన కంప్లీట్ ఐసోలేషన్ ఏంటి, ఇక్కడ కంప్లీట్ అయిన ట్రాన్సాక్షన్ అయ్యాకనే సెకండ్ దానికి వెళ్ళి T2కి వెళ్ళి కంప్లీట్ అవుతుంది. అప్పుడు వరకు T1 అనేది హిడెన్ లో ఉంటుంది. ఓకేనా, సో ఫస్ట్ ఇది కంప్లీట్ అయ్యాకనే నెక్స్ట్ T2ది కంప్లీట్ అవుతుంది. సో ఫస్ట్ ట్రాన్సాక్షన్ ఇస్ కంప్లీటెడ్ అంటిల్ T2 will be in waiting state or in partial committed state. Next, durability. Durability is nothing but whatever the transactions we have done, whether it is successful or unsuccessful, all the history it is going to maintain. Happened history, happened data it is going to maintain. Okay, even the system failure occur, the data it is going to maintain. Example, best example is our phone pay. If you open the history of the transaction, even it is failure or even it is successful transaction also, it is going to show all the history. Best example for durability is phone pay. Okay, so these are the acid properties. Is it clear? Yes or no?
ఎస్ మేడం.
Next, serializability. So serializability is, before going to serializability, we need to write about the schedule. What is meant by schedule? A sequence of actions or instructions performed in a chronological order, in a sequence order. When we are doing the concurrent transaction, parallel transactions are happening means a sequence should be maintained. Then only we call it as a schedule. So schedule is of two types: non-serial schedule and serial schedule. ఓకేనా, షెడ్యూల్ 1 లో ఏముంది, ఇక్కడ ₹50 ట్రాన్స్ఫర్ ఫ్రమ్ A to B and T2 is transferring 10% of balance from A to B. So what is our first one? రీడ్ అవ్వాలి. ఎక్కడి నుంచి 50 A to B కి రీడ్ అవ్వాలి. రీడ్ A ఈక్వల్ టు A-50, రైట్ A, రీడ్ B 50. ఇక్కడ ట్రాన్స్ఫర్ అయిపోయింది. వాట్ ఈస్ ద సెకండ్ కండిషన్? T2, ఇట్ షుడ్ ట్రాన్స్ఫర్ 10% of balance from A to B. అంటే we need to give the condition temp equal to A into 0.1, A equal to A minus temp, write A, and B equal to B plus temp, write B, commit. Okay, so this is schedule 1, serial schedule. After T1 completion, T2 is executed. T1, next serial schedule. After T2, it is followed by T1, like that. Next, serializability. Serializability, it is a very important concept. This is also, so serializability is used to find the given non-serial schedule is serializable or not. So coming to serializable schedule, it provides a consistent result, whereas non-serializable, it gives an inconsistent result. So the serializable schedule is equal to result of its transaction executed serially. Coming to this one, it is a result not equal to the result of transaction executed serially. Okay, these are of two types: conflict and view serializability. Conflict is nothing but conflicting the conflict serializability is used to check whether a given non-serial schedule is conflict serializable or not. So how we are going to check means by using the process of converting non-serial schedule into serial schedule by swapping its conflicting operations. ఓకేనా? ఎలా చేస్తామంటే కాన్ఫ్లిక్ట్ లో మీరు గుర్తుపెట్టుకోవాల్సింది నాన్ సీరియల్ షెడ్యూల్ ఫస్ట్ ఇస్తారమ్మా. దాన్ని మీరు సీరియల్ షెడ్యూల్ గా చేయాలి. ఎలా చేస్తారు? స్వాపింగ్ చేసుకుంటూ చేయాలి. నాన్ కాన్ఫ్లిక్ట్ ఆపరేషన్స్. ఇక్కడ 4 కేసెస్ ఉన్నాయి. ఏంటి? రీడ్ క్యూ. రీడ్ క్యూ అంటే both are read if the two transactions are performing two read operations perform చేసినప్పుడు it will not conflict. ఓకేనా? if at all a transaction, any one of transaction is having the right queue, then they can conflict. ఓకే, ఇది గుర్తుపెట్టుకోవాలి. 4 కేసెస్. రీడ్ క్యూ అంటే it will not conflict. If at all it is having any of the transaction is having right queue means we can consider as a conflict. So conflict లో ఎగ్జాంపుల్ చూడండి ఇక్కడ. T1, T2 is there. T1, T2 is there. Forget about this schedule 6 now. So listen here. Schedule 3 is having the transaction read A, write A. Next read A, write A. Read B, write B. Read B, write B. So how we are going to swap? First we need to swap read A, write A ఉన్నాయి కదా. So how? Read B, write B పైకి పంపించేస్తే కిందకి ఏమొస్తాయి? read A, write A. ఇక్కడికి వచ్చినాయి చూడండి. So this is what? This is non-conflicting and this is the conflict serializability. Why? Because we have swapped the non-conflict operations or non-conflict instructions. Okay. Next, view. So view serializability will going to find out the given schedule is view serializable or not. If a schedule is view equivalent, a serial schedule should satisfy 3 conditions. ఏంటి ఆ కండిషన్స్ అంటే ఇనిషియల్ రీడ్, ఫైనల్ రైట్ అండ్ అప్డేట్ రీడ్. ఇనిషియల్ రీడ్ if the both the schedules must be in same, suppose schedule S1 and S2 are there. ఇక్కడ రీడ్ ఏ ఉంది, రైట్ ఏ ఉంది. వాట్ ఈస్ ఇనిషియల్ రీడ్? ఇక్కడ T1. ఇక్కడ ఫైనల్ రైట్ వచ్చేసి T2. ఇక్కడ S2 లో ఫైనల్ ఇనిషియల్ రీడ్ వచ్చేసి లేదు. ఓకేనా? ఇక్కడ నిల్. సో దీస్ 2 ఆర్ కాల్డ్ as నాన్ ఈక్వివాలెంట్. Update in schedule T updated by TJ, then S2 is also TI is updated by TJ. So here it is non-serial schedule. S1, T1, T2 R of A or W of A non-serial. Serial ఎక్కడ అవుతాయి? అన్ని T1 ట్రాన్సాక్షన్ కంప్లీట్ అయినాక T2 ట్రాన్సాక్షన్ కంప్లీట్ అవుతుంది. దాన్ని మనం సీరియల్ షెడ్యూల్ అంటాం. హియర్ అప్డేట్ లో ఏమవుతుందంటే ఇక్కడ అప్డేట్ ఏమవుతుంది? T2 లో అవుతుంది. సో హియర్ షెడ్యూల్ ఆఫ్
మేడం
చెప్పండి.
మీ వాయిస్ క్లారిటీగా లేదు మేడం.
ఇప్పుడు వినిపిస్తుందా?
మేడం
Next, final right. So final right is nothing but it is a must be given between the both the schedules S1 and S2. So in schedule S1, if a transaction T1 updates a last S2, final right operation should also be done by T1. So here S1 schedule లో final right అనేది T1 లో ఉంది అండ్ T3 లో కూడా ఉంది. ఇక్కడ కూడా ఫైనల్ రైట్ అనేది T1 లో ఉంది, T3 లో ఉంది. సో దిస్ ఈస్ కాల్డ్ యాజ్ అ వ్యూ ఈక్వివాలెంట్. వ్యూ ఈక్వివాలెంట్ అంటే ఏంటి? ఈ 3 కండిషన్స్ ఏవైతే సాటిస్ఫై అవుతాయో ఆఫ్టర్ కన్వర్టింగ్ ఇంటూ షెడ్యూల్ S2, దట్ ఈస్ కాల్డ్ యాజ్ వ్యూ ఈక్వివాలెంట్. ఓకే, ఇస్ ఇట్ క్లియర్?
ఎస్ మేడం.
నెక్స్ట్ కంకరెన్సీ కంట్రోల్.
మేడం
చెప్పండి.
రికవరబిలిటీ అంటే ఏంటి మేడం?
రికవరింగ్ ఫెయిల్యూర్స్ ని ఎలా రికవర్ చేస్తారో అవి. దానికి కొన్ని స్టెప్స్ ఉంటాయి, కొన్ని ప్రోటోకాల్స్, టైం బేస్డ్ ప్రోటోకాల్స్, లాగ్ బేస్డ్ ప్రోటోకాల్స్, అవి. ఓకేనా? రికవరబిలిటీ అంటే అవే.
అంటే
ఎలా రికవర్
రికవరబుల్
డేటాబేస్ ని ఎలా రికవర్ చేస్తారు యూజింగ్ సమ్ కాన్సెప్ట్స్, అంతేనా? ఇప్పుడు డేటాబేస్ ఉందమ్మా, నా డేటాబేస్ నాకు ఫెయిల్యూర్ వచ్చి ఏదో సమ్ సిస్టమ్ క్రాష్ అయ్యి ఫెయిల్ అయ్యింది. ఎలా రికవర్ చేయాలి నా డేటాబేస్ ని? యూజింగ్ సమ్ ప్రోటోకాల్స్, టైం బేస్డ్, లాగ్ బేస్డ్ ప్రోటోకాల్స్ అవన్నీ ఉంటాయి కదా, కంకరెంట్ ట్రాన్సాక్షన్స్ అవన్నీ యూజ్ చేసి చేస్తాం.
ఓకే
ఓకేనా?
మేడం. అలాగే 2 టైప్స్ ఉంటాయి మేడం దాంట్లో.
2 టైప్స్ ఉంటాయి, లాగ్ బేస్డ్, టైం స్టాంప్ బేస్డ్ అని.
రికవరబిలిటీ వేరు, రికవరబుల్ ఏబిలిటీ వేరు మేడం.
లేదు సేమే.
ఓకే మేడం. ఓకే థ్యాంక్ యూ మేడం.
So concurrency control techniques. So concurrency, it is a process of managing simultaneous execution of transaction in a shared database. Like if you are going to ATM, different people are accessing the at the same time. నేను ఒక ATM మెషిన్ లో యాక్సెస్ చేస్తుంటాను, లేకపోతే ఒక ATM మెషిన్ బ్రాంచ్ తీసుకోండి, 2-3 మెషిన్స్ ఉన్నాయి, అక్కడే సైమల్టేనియస్ గా different people can access the ATM machine at the same time. So all the customers of SBI account will withdraw money from ATM. That means it is a shared data. ATM అనేది ఇక్కడ shared data. ఓకేనా? So multiple transactions are done in the same database called as concurrency control. Parallel transactions. నేను ట్రాన్సాక్షన్ చేస్తున్నాను, వేరే వాళ్ళు ట్రాన్సాక్షన్ చేస్తున్నారు, సేమ్ ఎట్ ఎ టైమ్. దట్ ఈస్ కాల్డ్ as a concurrency. So purpose of concurrency control to enforce the isolation. So here everyone knows that whatever the database is there, that should be isolated. Why? For the security issues, we need to isolate the data, and to preserve the database is in consistent state. Always database should be in consistent state only. Next, to resolve the conflicts, we need to use the operations like read, write, read. Okay, after completion of T1 only we should complete the T2. అలాంటి ప్రోటోకాల్స్ పెట్టుకున్నప్పుడే సో ట్రాన్సాక్షన్స్ విల్ బి in protected mode. So techniques of concurrency control are log-based protocol, timestamp, optimistic, multi-version. So log-based protocol అంటే ఇవన్నీ రికవరీ అండ్ అటామిసిటీలో వచ్చేస్తాయమ్మా. నేమ్ ఇట్ సెల్ఫ్ సేయింగ్ లాకింగ్ ది ట్రాన్సాక్షన్. ఓకే, లాగ్ బేస్డ్ ప్రోటోకాల్. ఎలా ప్రొటెక్ట్ చేస్తాము, ఎలా రికవర్ చేస్తాము అన్ని ఇందులోనే వస్తాయి. ఓకే, సో వాట్ ఎవర్ ద ట్రాన్సాక్షన్ ఈస్ డన్, first locking its transaction and doing operation and then releasing the transaction by unlocking that. Okay, a lock guarantee exclusively use the data items to current transaction. First access the data items by lock acquired. After completion, release the lock. Different types of locks ఉంటాయి, shared lock, exclusive lock. Shared lock also called as lock yes. Exclusive lock also called as lock V. Shared lock lo transaction can read the data items only. Shared lock lo. Exclusive lock lo we can use read, write data items. Okay na? Only read endulo shared lock lo. Exclusive lo read, write chestam. That is log based protocols. So number of transactions can hold the shared lock, but exclusive lock can hold only the lock at a time. Timestamp based ante based on the starting time of the transaction, it is going to calculate. It is going to identify a uniquely. Okay, timestamp based. Timestamp values ఉంటాయి, read timestamp, write timestamp అని. Next, operations and B plus tree. సో ఇందులో కూడా ఇన్సర్షన్, డిలీషన్. ఒక 5 minutes లో క్లోజ్ చేస్తానమ్మా. So here main operations of B plus tree are insertion, deletion, and search. So first of all, what is meant by B plus tree? This is a self-branching search tree, so which is used in a databases and file system so that they can handle large amounts of data and maintains a balanced performance. So like B plus tree, it is a cost search, insert, delete operations will be a depth of a tree. So B plus trees will have every node in the tree except a leaf nodes. So the tree only gets a taller when the root node is split into the two or new root nodes. So what are the operations means? Insertion, adding a new key to a tree while maintenance of its balance. So here it is called as a node is a full. So here the split into will be two nodes and middle key is moved to the parent node, that is insertion. Coming to the deletion, removes a key from a tree while maintaining its balance. This may require borrowing a key from siblings, nothing but root child nodes, or merging the nodes. Coming to search operation, it finds a key within the tree nodes. The search process is similar to binary search and take the advantage of sorted keys. Okay, so these are the operations, three operations you need to write about the B plus trees. Is it clear? So these are the 5 units. Very easy. From first unit, definitely you'll be getting DML, DDL operation, not DML, DDL, data model, schema, instance, and view level. Okay, and architecture they can ask, and also they can ask the ER diagram. Second unit, relational model, and what are the key constraints, and nested queries, not nested queries. They can ask the SQL queries also here. Write about the syntax of creating a table, alter a table, update a table, delete a table, like that. Okay, and learn the database languages, 4 types: DDL, DML, DCL, TCL in second unit. Next, coming to the SQL, learn relational algebra perfectly, fundamental operations, relational operations, and nested queries, and how to order, how to group by use having and aggregation functions. Coming to the fourth, functional dependencies, multi-valued dependencies, lossless, what is decomposition, all those things. Coming to the normalization concept, learn 6 normal forms. Okay, completely. So these are very important. Fifth unit, acid properties, serializability, and sometimes they may ask failure classifications also. And also important one is operations. These 3 operations: insertion, deletion, and selection. Okay, so these are the 5 units. Prepare well and write the exam properly. Learn each and every point. First, write definition, then syntax, and then example. DBMS లో ఎప్పుడైనా టేబుల్స్ డ్రా చేయడానికి ట్రై చేయండి అమ్మా. టేబుల్స్ డ్రా చేస్తేనే మీకు నాలెడ్జ్ ఉన్నట్టు అర్థమవుతుంది. ఓకేనా, కరెక్షన్ చేసే వాళ్ళకు కూడా. ఇస్ ఇట్ క్లియర్? ఎస్ ఆర్ నో?
మేడం,
చెప్పండి అమ్మా.
ఫెయిల్యూర్ క్లాసిఫికేషన్ అంటే ఏంటి మేడం?
ఫెయిల్యూర్ క్లాసిఫికేషన్స్ ఇన్ డిబిఎంఎస్.
ఎస్ మేడం.
చెప్పాను కదమ్మా ఇప్పుడే, ఫెయిల్యూర్ క్లాసిఫికేషన్స్ పీపీటీస్ లో పెడతాను. ఇందులో లేదేమో. Then failure classification in DBMS means logical errors. ట్రాన్సాక్షన్ ఫెయిల్యూర్ అయినప్పుడు ఏం ఎర్రర్స్ వస్తాయి? లాజికల్ ఎర్రర్స్, సిస్టమ్ ఎర్రర్స్ వస్తాయి. ఓకేనా. నెక్స్ట్, సిస్టమ్ క్రాష్ అయినప్పుడు ఏం ఎర్రర్స్ వస్తాయి? పవర్ కట్స్. నెక్స్ట్, మాల్ ఫంక్షన్స్, సాఫ్ట్వేర్ మాల్ ఫంక్షన్స్, బగ్స్, ఎర్రర్స్, సాఫ్ట్వేర్ ఎర్రర్స్, లేదంటే ఓఎస్ ట్రిప్ అవ్వడం, అలాంటివి జరుగుతాయి. సిస్టమ్ క్రాష్ అయినప్పుడు. నెక్స్ట్ డేటా ట్రాన్స్ఫర్ ఫెయిల్యూర్స్లో డిస్క్ హెడ్ క్రాష్, డిస్క్ unreachability, formation of bad sectors. So failures of classification in DBMS ఏంటి 3 types: transaction failures, system crash failures, data transfer failures. Transaction failures అంటే లాజికల్ ఎర్రర్స్, సిస్టమ్ ఎర్రర్స్. సిస్టమ్ క్రాషెస్ అంటే పవర్ కట్స్, మాల్వేర్ ఫంక్షన్స్ ఏమైనా ఉంటే మాల్ ఫంక్షన్స్, అండ్ బగ్స్ ఇన్ సాఫ్ట్వేర్స్ అండ్ ఓఎస్. నెక్స్ట్ డేటా ట్రాన్స్ఫర్ అయ్యేటప్పుడు ఫెయిల్యూర్స్ ఏముంటాయి: డిస్క్ హెడ్ క్రాష్, డిస్క్ అన్రీచబిలిటీ, ఫార్మేషన్ ఆఫ్ బ్యాడ్ సెక్టర్స్. ఓకేనా?
ఓకే మ్యామ్, థ్యాంక్ యూ మ్యామ్.
సో ఆల్ ద బెస్ట్ ఫర్ యువర్ ఎగ్జామ్. రైట్ వెల్ మా. ప్రిపేర్ అవ్వండి, అన్ని యూనిట్స్ ప్రిపేర్ అవ్వండి. ఎగ్జాంపుల్
మ్యామ్.
రాయడానికి ట్రై చేయండి. క్వెరీస్ రాయండి. ఎగ్జాంపుల్స్ లో క్వెరీస్ మెన్షన్ చేయండి. ఇప్పుడు డిఎంఎల్ ఆపరేషన్స్, డిడిఎల్ ఆపరేషన్స్ అడిగినప్పుడు ఒక్కొక్క దానికి ఒక్కొక్క ఎగ్జాంపుల్. అగ్రిగేషన్ ఫంక్షన్స్ అడిగినప్పుడు ఒక్కొక్క దానికి ఒక ఎగ్జాంపుల్. సెలక్షన్ అదే ఆల్జీబ్రా అడిగినప్పుడు ఒక్కొక్క దానికి ఒక ఎగ్జాంపుల్. యాసిడ్ ప్రాపర్టీస్ అడిగినప్పుడు ట్రాన్సాక్షన్ అటామిసిటీ ఎలా జరుగుతుంది. ఓకేనా? ఏ నుంచి బికి ఎలా ట్రాన్స్ఫర్ చేస్తున్నారు, ఆపరేషన్స్ అన్ని రాయాలి. రీడ్ రైట్ ఆపరేషన్స్. ఓకేనా? అవన్నీ రాయండి మా. ప్రాపర్గా రాయండి. ప్రిపేర్ వెల్ అండ్ రైట్ ద ఎగ్జామ్ ప్రాపర్లీ. ఆల్ ద బెస్ట్ మా.
థ్యాంక్ యూ మేడం.
థ్యాంక్ యూ మ్యామ్.
యూ కెన్
మేడం ఫస్ట్ యూనిట్
మేడం
నుంచి
పీడిఎఫ్ పంపించండి నాకు ఓవరాల్ గా.
పంపిస్తాను సార్.
ఫస్ట్ యూనిట్ నుంచి 5th యూనిట్ వరకు పంపించండి.
ఓకే సార్.
ఓకే
థ్యాంక్ యూ.
ఓకే గాయస్.